All right, here we go. Day whatever. Um, should try to keep up with this more often, but we'll get there. So coal extracted from mine at a rate that is proportional to the amount of coal remaining in the mine. Hence, the remaining R after T years is given by that formula where K is a constant, RO is the initial amount of coal. After 20 years, half of the coal remains. So what we want to say, we want to find K, but in this case we can see that T is equal to 20. And the other one to notice here, R is equal to half RO. Now, why I'm saying that, because R is, where is it? R is the remaining, and RO is the initial. But after 20 years, we're told the initial amount is down to half. Now, the reason why I'm substituting that in here is because I can see an RO in the equation. So what I'm going to say here is that half RO is equal to RO e to the minus K times 20. Now, what I want, the whole reason why I want to do the RO thing was because we've got RO on both sides, and whatever value that is, we can get rid of it because it's on both sides of the equation. And I'm going to tidy up that other side. So I've got half is equal to e to the minus 20k. Now we want to do some work with our ln's. So we're going to say ln of both sides. Half is equal to ln e to the minus 20k. All right, and then we're going to do just a little bit of work with our log laws. I'm hoping that on the other side, though, that you can see what's going to happen with the e and the ln. From here, we've got division, so I won't skip a step. I'll say ln of 1 minus ln of 2. That's log law 2. And that is just equal to minus 20k. And don't forget, throughout this whole thing, we can see this word again, exact. So please don't use a calculator. You do need to know ln of 1 is 0. So we're going to say minus ln of 2 is equal to negative 20k. Then ln. Sorry, just trying to find the eraser. Where is it? Scribble it out. Nope. I really should have done. There we go. Okay. Negative. Oh no, I want to be positive. ln of 2 on 20. 2 minuses go away. Is equal to k. All right. Now, so that's the first bit done, which is good. We haven't used a calculator. Go to the next one. It says, how many more years will elapse before only 10% of the original amount remains? Again, we're going to go back to the formula and we're going to use what we know about the RO again. So, except this time, this is almost like a rinse and repeat thing this time. Except this time, we're going to say R is equal to 0.1 RO, being 10% of the original. So we're going to say 0.1 RO is equal to, what was that formula again? ROE. And then don't forget that this time we've got to change the value of K because we said K was equal to that. So it should look like, and we're trying to find T this time. So we're just substituting in what we know for K. So this should be minus from the thing, minus ln of 2 on 20 to the t. Again, same with the ROs again, they disappear. So we've got 0.1 is equal to e to the minus ln of 2t on 20. Then again, what are we going to do? We'll hit both sides of that with ln. And don't forget, we're going to use our, we're going to do some other little magic here. So I might as well explain this one. I'm going to hit both sides of ln. 0.1 now, I'm going to change that into 1 on 10 so I can use my log law. So I'm going to say ln of 1 on 10, which is the same as 0.1, is equal to ln of, I wasn't going to write it, but I will, ln of 2 of 20 to the t. Okay, and the same thing happens with the 1, so that gets broken up. I'll just write it here. I'm not going to write the other part on the other side again. 1 minus ln of 10. And then we've got negative ln of 10 is equal to the negative ln of 2t over 20. And then we want to get t by itself. How do we do that? We can multiply just like we would as in a normal equation. I feel like I'm just right over top of myself here. And then we'll go here. So I'm going to bring the minus 20 across, so that becomes a positive 20. ln of 10 is equal to ln of 2t, and then t is equal to 20 ln 10 over ln of 2. And t, I believe if you put that into your calculator, you should get 66.43. T is equal to 66.43. All right, but if we answer the question, it's asking for how many more years, not how many years to get there. So you've got to remember from the first part of the question, we're already at 20 years. So we have to take off 20. So 66 minus 20 is going to give us, and did I write that down right from the calc? Oh, sorry, 66.43. And then we're going to take off 20. So we should get 46.43. And nice. There we go. And I feel that took like a long time. And it did. That's all right. Okay. This one, differentiating from first principles. So this sort of question, for me, I like to just put over to the side what the answer should be. So if you know from normal differentiation, that should be 2x minus 4. And then let's go about the business of doing that. So the derivative, so what we need to do equals as lim. Yes, you must put the limit as h approaches 0 in there. And then we're going to say x plus h squared, because I'm replacing where I see the x's, I'm going to put x plus h minus 2 lots of x plus h. And I'm going to minus the function itself, which is put in brackets x squared minus 2x. Be careful if you don't do that part. Sort of a lot of students will forget that. And then again, as limit as h approaches 0 do some expansion. Hopefully another shortcut that square the first term, so x squared, 2 times both those terms in the middle, so 2 times x times h gives me 2xh plus h squared minus 2x minus 2h minus x squared plus 2x all over h. Can we get rid of some things? We can. The x squareds go away. The 2x goes away. And all I'm left with is equal to lim h approaches 0, 2x plus h squared minus 2h all over h. From there, you want to factorize out a h, so you can cancel with the bottom. Lim as h approaches 0. So we're going to have h outside of 2x. Oops, I shouldn't have said 2x plus 4 up the top. What am I thinking? 2x minus 2. Saturday morning. Go Menzies. Plus h minus 2, which looks a lot better, all over h. And then when you go for the final part of this answer, this is where you substitute in for your h is equal to 0. And this is the step where you don't have to write the limit approaches h approaches 0. Because what you want to do from this step is say, hey, those h's go away. But you want to replace that h with 0. So if you do, all you're left with is 2x minus 2, is what we needed to get. Whoa, that took a lot. Do we have enough time to do that to marker? Yes, we do. Again, this is another little log one. Loudness in decibels given by the formula that where I is the intensity level and IO is the threshold. Sounds louder than 85 dB can damage hearing. The intensity of a vacuum cleaner is 10,000 or 10 million times the threshold level. Would using a vacuum cleaner damage your hearing? Justify your answer. So what you can say is the intensity in this one comes straight from, without moving everything. Go back. 10 times 10,000 times the threshold, IO. So what we're going to say here is L is equal to log E 10 million, 1, 2, 3, 1, 2, 3, times the intensity, IO, over IO. You got IO and IO on top and bottom, so regardless of what they are, you can get rid of them. It's the same. You can, log E is the same as the natural log, and so you got the natural log of 10 million. And if you do the natural log of 10 million, I believe you get the answer of something like 16. Okay, so you get 16.11. 16.11, and we'll put it in decibels. You have to some sort of statement. No, it would not damage hearing. Not damage hearing. As less than the 85 decibels. All right, so that's part one. Yeah, that's part one done there.